Hello everyone, welcome to my YouTube channel. Thank you for supporting me. Today we will do basically a project on machine learning, and you will understand how the data scientists are actually working in a real world. So let's jump into that. Okay, again, as I mentioned, today this project or this demonstration will be very helpful for you. Like if you're planning to work as a data scientist and if you're planning to work on a real data or real project. So what this project all about? This project is all about student performance analysis using the non-academic features. Especially if you are from India and if you are um, aware of little bit about the private institutions, a lot of time, even government institutions nowadays, they are educational institutions. They are looking for a lot of non-academic information also at the time of admission, like what your father's education, what is your background, those kind of things actually. And one of the motive is basically try to understand a student's success and failure or student's performance based on the academic background. And that's basically the intuition of this project. So I will share this notebook. So a lot of things I have documented it here so that when you actually read through these things, you can understand it thoroughly. So I will go through this thing now for the channel. Okay, so I will jump on. I took this data from the Kaggle, and these data sets, I will provide these data sets also into my GitHub page. This data set is actually having these many features. Not many features, it has gender, your race, your parental level of education, lunch, are you taking a lunch from home, are you taking a free lunch in the school, this kind of thing. Test preparation course, have you taken any test preparation course? Yes, none, completed, something like that. And what is your score probably in your last class or last semester or something, last school, whatever that is. The motivation of this project is basically, can we predict a student's performance just by these non-academic features? Because if you have these academic features, then it is very easy, right? You can just simply say whether it's good or bad. But a lot of time, um, these features are also very crucial to gauge whether the student will be successful or not. And based on that, institutes are actually taking a very good measure, actually, good process to um, evaluation and all those things they are implementing and helping the students actually. So this kind of models actually identifying those kind of students where probably they need a little bit more attentions, and institutions are doing a great job. Okay, so again, gf.info will give me a lot of different informations like how many features are there. I have 1000 features. How many, sorry, 1000 observations or what, 1000 statistical units, how many features are there or how many predictors are there. Now, if you know about supervised machine learning, you probably have already a question in your mind. That is, okay, I have all the features, all the predictors, where is my response? And for supervised machine learning, you need a labeled data. So that's mean this is a unique case because this is the real example. A lot of time, what you have to do, you have to build as a data scientist, you have to build that particular target variable or response variable. Okay. Now, as a data scientist, you might think, okay, what are the different way I can build this target variable? One thing I can do, probably I can just sum it and divide by 3 and then put an average score, right? That's a good way of finding out the average score. And based on that, I can guess like, okay, based on these features, if I can guess some kind of average score, that's, but when we consider about average score, that's mean it's basically a continuous variable, right? So if we calculate the average score, it will look like this. And based on this average score, we can try to build a regression model. As a data scientist, a lot of time this is a question at the very beginning, it's coming to you when your response variable or your target variable is not available, you are deriving that, then it is a question, should I make this variable as it is so that I can build a regression model, or should I make it like this so that I can make a classification model? Very interesting question. And by the time I know you are regression and classifications, you are our classifications when you have a discrete uh, response or target variable. So as a data scientist, probably I thought, okay, I will go with the regression approach. And basically what I'm trying to do, I'll build a model which will use these features as my basically predictors and try to predict average score. Now, whoever is already expert in this kind of world, machine learning, probably you can tell it right now itself that regression is not a good fit. But as a data scientist, you need to prove it, right? That, okay, regression is not a good fit for this kind of data points. So always when you have a data, you have to do some kind of exploratory data analysis. And I also did the same thing. I just make sure there is no null values. Again, if you have a null values, that's mean you have to do some kind of imputations. Okay. Univariant analysis, always it is recommended, because by that way you can identify if there is a drastic difference. Like I'm not seeing any big drastic change anywhere. Like probably you find that, okay, all are female, there is no male data at all. And some of these observations are crucial actually. I'm not seeing any such observations. Always after the univariant analysis, the next step is outlier. Right now, just by seeing these data points, I can see there is no such outliers. And obviously, these are my categorical variables. And when we'll do on the numerical side also, you'll see there is no outlier. So right now I'm not doing any kind of outlier analysis. Otherwise, another step is you have to basically identify the outliers and think about, do you need to remove it or not, especially if you are planning to impute the null values by the mean or something, mean values actually. Then outlier is very crucial. And in a one video, I'll show you how outlier is actually impacting the mean imputation. Then we are doing the multivariate data analysis, and this is a lot of these things you can just focus. Like for example, I did a multivariate with male and female, an average score, and what I saw that, okay, the female's average score is a little bit higher than male. So female or the girls are actually doing better than the boys. Okay, so this kind of things, all these things can tell some story, like which one is doing the better things. So this code should help you on those kind of analysis, and from a certain point of view, we can understand what is important or not. Next is basically a bivariant analysis, or basically a correlation plot, right? Now, obviously, if you do a correlation plot by average score and these values, you can see that interesting observations here. If we try to build a linear regression model using these features are actually multicollinear. There is a problem of multicollinearity. All these features, math score, reading score, writing score, they are highly correlated with these features, and they are individually correlated also. If writing score is high, like for example, um writing score and reading score, yeah, look, so high. So obviously, if you are an expert person, you'll probably by this time you know that linear regression is not a well fit in this kind of a scenario. We still continue. We just make sure we converted all the categorical value to numerical value, and again plotted with the now we are plotting with the average score and basically all the non-academic. And what we found, there is no significant linear relationships actually. So if you do not have a no significant linear relationships with any of the attributes, probably it is not at all a good case for linear regression kind of or regression kind of a problem at all, especially linear regression kind of a problem at all. Okay, so what is next? We still thought, okay, because you want to still understand, right, that if we do it, what's the problem? Like, okay, we understand from this graph that it's probably not the right thing, but we still go ahead and do the model building actually. So we just split it with the twin and test, and then we use the random forest, and then we use all this plot. I'm not going much in detail because this notebook will be available to you. You can just go through and you can completely understand all the code. And especially in all the places, I use the random state equal to 40. So if you run it as it is, you should get the same result. One more time, if you got stuck anywhere, don't forget or don't hesitate to email me or send me a message. I can try to help. So what we observed actually that with the linear regression, our R square value are coming very, very low. And by the time I think you're kind of know that R square is one of the indicator. If the R square value is more towards the one, that's mean it's a good indication that the model is giving me the good result actually, right? So in this case, all the R square values are very low. So we are kind of, and our plots were also suggesting that the we cannot consider it's a we cannot deal this problem by regression analysis. Make sense? Look how interesting this project. You got the data, but there is no label data. You build that level and then you analyze and you find out, okay, regression is not the right model. Then what is the next? Then we will apply the classification problem. Not logistic regression is one kind of algorithm, but classification problem actually. Okay, so for classification, that's mean we have to deal the target variable or the response variable again different way. And what we are doing, we are now basically put a cutoff value for the average score, and then we create a success parameter which is telling me, okay, if it is success or failure. Like for example, this student is having very low score in all the things, and it is failure because my cutoff point is 205. Now I prepared the data like this way because this is my classification problem. Now I want to classify it just, okay, success or failure. Okay, and with a cutoff. Now this cutoff may vary from institute to institute. For me, I put a 205. In other institute, maybe it will be 175 or something. So that cutoff point is completely on a subject matter expert or an institute expert actually, whatever institute you are working on and what data you are handling in that institute. But understand the different aspects actually. Okay, obviously, next step is we have to convert all these categorical features into the numerical features, and in a lot of time I use this get dummy functions and in another video, because this will again take some time to explain all the things how it is doing. But just understand these things are basically converting these categorical features into the numerical features and how it is working. Like for example, gender. In the gender, we have two different distinct values. One is a female, another is a male. So what it is doing, it's basically saying that, okay, if male is, it is considering male is 0 and female is a 1. So you can bring both of them, but if you bring both of them, unnecessarily you are bringing one extra feature in your data set. So you don't need it, because by saying this that male is 0 or 1, you are already telling whether it's male or female. So you don't need another column actually or another feature. That's why we are dropping the first actually. Okay. So interestingly, we built this thing, and then another thing, once we build that data, we did a check whether our data is imbalanced or not. And this is very, very important. Like if you are working on a classification problem, because if your data is imbalanced, and I will in another project, I will show you like where you have an imbalanced data and how you have to handle it. But if you have an imbalanced data, then you cannot rely on the accuracy metrics. That's a very important point. Okay. But right now, because my data is not imbalanced, so I am relying on the accuracy metrics. As a next step, what I'm doing, I'm simply doing train and test split. And hopefully you can understand this piece of code if you're following my channel. A lot of time we did these things and you can understand these things. What probably something new about this line and this line, if you are not following, read this line with me very carefully. You can understand what I'm doing. Two versions of this data will be utilized. The first is the complete datasets, categorical and quantitative features, and the second is the datasets comprised of only the categorical features. The full version will be used as a comparison of the ability of the models to predict based on categorical features. Okay. So hopefully you understand what I'm trying to say, that I can use this complete data set and try to build a model. And I know I will get a very good accuracy. Why? Because I'm using these features also. But the intention is to check if I do not have this information, if I have only the non-academic values, non-academic features, can I still say something about the student? That's the important thing from the data. And if I can say, or if I can misclassify some of them, or if I say I correctly identify some of them, that's the benefit, because then I can, that institute can prepare some extra plan, extra curriculum, and a lot of institutes are doing this. They are great in this kind of things actually. So what I did, I basically created two sets of data, and my first intention is basically build the model using this data where I have all the features, and I will create a baseline model because I can understand, like, okay, I'll create two different model, because a lot of time if I do not have the information, then I can use one model, and if I have this information, then I can also use another model. And using this model, we found the accuracy and F1 score is really good. So we are great. But when we used only the non-academic, remember non-academic features, what we found that, okay, our accuracy and F1 scores are dropping, which is possible. But still, 70% accuracy or 73% F1 score is still significant for you to tell something about the story. And that's why this model is also important. Like by this kind of a model, you can tell that, okay, how many I'm getting absolutely correct. Okay, these are my good student I identified. These are my bad student I identified. But what about the persons I misclassified? Because after this, I plot this kind of basically the classification matrix and classification report. All of these things are telling me confusion matrix, sorry, pardon me, confusion matrix and classification report. From this, we can easily tell that, okay, the model is actually kind of identifying almost 32% or this many uh, true positive, true negative, false positive kind of thing. So what important is here, true positive, good students are good students. But if you are misclassifying something, because here you are misclassifying some of this thing and here you are misclassifying some of this thing, these are your vital points actually, which you can use for understanding, okay, what is going on with the students? Do you need a special treatment or do you need some extra class and some of these things? Okay, and this is just showing that if you use the original model, or I will say the base model, which has all the features, then you will get a more better results. But by chance, like when the student is coming completely of different background, you do not have this information, then you have to rely on those non-academic background actually. So still it is a quite a significant good amount of information it can provide from that categorical models or non-academic models. Now the coming best thing. As a data scientist, you need to also identify the best model, right? You cannot just rely on one single model like logistic regression or done. You cannot do that. What we have to do, you have to probably select multiple such models. Like in my case, for this session, what I did, I used the logistic regression. I knew the k nearest neighbors, and you can go through these things. K nearest neighbors, you have a separate session where I already explained this thing. And then you have XGBoost also, which I used. And I'm not going through these things. All these things are very much available here, and you can just simply run it. If you stuck anywhere, email me, message me, because you should run as it is. There should not be any problem. And I'll give the datasets also. But after comparing these three, you have to come out with some conclusion, right? Which model is the best model and which one you want to use for your institute or something, right? So all these models, like when we compare, you will see this from this confusion matrix, they are kind of giving me the similar kind of results, which is indicating that it's a good observation that all the models are giving me the similar kind of results, mean the that non-academic values are telling something very accurate informations actually. Okay, so which is good. Now, coming to the conclusion, what is the conclusion then? The conclusion is that using the non-academic values, probably I'm not getting the super accuracy, which mean that I cannot directly say that, okay, uh, by students' points, I can directly classify. That is true. But still, it's a very, very important that understanding the role that demographics or non-academics play is crucial in providing enough support to students who are danger being misclassified. What does it mean? If my model misclassified some of the things, okay? So basically, from this model output, I will easily understand, right, which are the students actually misclassified, and we can work on that actually. And for a new student, you can easily identify, right, whether you do not have that information, right? So you can basically check the success and failure. And based on that, based on your cutoff marks, also you can take a decision, right? Okay. Based on your cutoff marks, also you can take a decision that whether the person will be successful or not. And that is kind of a, if it is a person is successful, you're good. But if you are not successful, you can take that special case, like why the data is telling that probably this student will not be successful, and check it like, okay, what needs to be improved. Maybe you can do some more analysis and all those things. So this is a good way of handling this thing. This is another way you can say, like how institutes are doing the risk analysis also. Like when somebody is asking for or going for an interview or admission, they are doing this check probably, and then they are coming out with a better plan for those kind of students actually. Okay, so hope you like it. But one more interesting thing which I thought of just share you, like as a data scientist, a lot of time is documentation is so important. So probably go through this documentation, whatever I mentioned here, and also in my GitHub page, I will share presentation which you might just take a look, because a lot of times when you work as a data scientist, along with your work, you need to build your presentation also, so that you can present it to the external world actually. So that's all for today's video. I know it's a little longer video, but please stay with me. Please like and subscribe. Um, I will come up with this kind of projects more frequently. Thank you so much. Have a blessed day. Have a nice day. See you in the next video.